Hello, everybody, and I would like to get started right away. It is our Friday afternoon speaker series. It's November 20th. I'm Robin Silvestri from Save the Great South Bay. Save the Great South Bay is a 501c3 nonprofit. We are active here on the South Bay, the Great South Bay. And we've been active here for about 7 years now. We started in 2013 when two Sayville High School graduates had returned for a reunion, and were just in great despair at the state of the bay back at the time. We had had an influx of brown tides, mahogany tide, blue-green tides across the Great South Bay that led to a lot of beach closures, erosion of our shellfish populations, and a general degrading of the Great South Bay. So today we are here as part of our speaker series. This is a series where we gather the best of the best and their knowledge to share with us across the Great South Bay. Today's presentation is a more open to a more general audience, although we have quite a few of our partners on here, including Trustee Kevin Smith from the Amityville Mayor's Office. Thanks for joining us, Kevin. We have Greg Rivara, who is part of our Great South Bay Oyster Project Advisory Board. Thanks for joining us, Greg. We have Rich Grove from our partners over at the Town of Babylon and their Environmental Control Department. With I see Emily is here with us as well. And of course, we have a science classroom from West Hampton Beach High School with teacher Mrs. Diana Gobler. So welcome everybody from West Hampton Beach High School. How our speaker series work is I make a short introduction to our speaker. He will then, Dr. Gobler will then provide us with a 20-minute presentation. I'm going to ask everybody to please keep yourselves muted and hold all your questions to the very end. We will have plenty of time for questions, and I'm sure on this topic there will be plenty of them. Thank you. I see Ethan. I see Ethan has joined us as well. Ethan is with the Great Gino Macchio Foundation, a big partner for us out in our Great South Bay Oyster Project. So welcome, Ethan, and thanks for joining us. All right, so with that, Dr. Gobler, I'm going to turn the floor over to you. You should have the ability to screen share.
I do, and I guess you'll be able to admit people then, right? Because I've actually been helping with that.
Oh, terrific. John's going to do that as well. So Dr. Gobler is a professor over at Stony Brook University, School of Marine and Atmospheric Sciences. He has been conducting data collection along the Great South Bay for the last 13 years and providing periodic report cards of it. He also runs the Gobler Laboratory up at Stony Brook University, and we are really excited to welcome you today, Chris. So thank you so much for joining us. Thank you for your time.
That's my pleasure, Robin. Thank you for the invitation to speak. And while my one monitoring program has been sampling Great South Bay consistently since 2013, as I prepared this talk, I reflected upon the point that my first sampling of Great South Bay was for a brown tide in June of 1992. So I have quite a legacy there and did a lot of sampling of Great South Bay through the 90s and beyond. I want to start by acknowledging all the wonderful young people who work in my laboratory. It's an amalgamate of graduate students, technicians, and postdocs who really do all the work and make things happen. And they're a real pleasure to work with. You can follow what the Gobler Lab does on social media, be it Instagram, Facebook, or Twitter. And an important starting point for this presentation will be the concept of a watershed, which I'm sure we're all pretty well aware of, but you know, this concept is so acutely important on Long Island because of the fact that any water falling on land, not only does it become our drinking water source, and that's shown here, entering the groundwater. Well, and enters our groundwater and it becomes our drinking water source. So that's like incredibly important. And thereafter, of course, whatever is not used for drinking water, it's the leftover groundwater that then discharges into streams and then, of course, into our coastal bays, like Great South Bay. And we know the trends on Long Island with regards to both population of Suffolk County as well as the which is shown here on the left, But here also is what's been happening with regards to nitrogen in our groundwater. A steady increase in concentrations to a level now at 3.8 milligrams per liter on average. This is higher than 95% of the United States. And when I say that, it's not just simply a random number. There was a study that was done just last year by Duke University that plotted out all of the drinking water nitrogen concentrations. So 95% of the country has lower levels of nitrate than we do. And while my talk today will emphasize how the high nitrate affects coastal ecosystems, I want to just point out that there's emerging epidemiological evidence that high nitrate at this level can also be a human health concern with regards to carcinogenic effects. So a decade or more ago, if I did this talk, the question would be, well, where's this nitrogen coming from? Why is it increasing? Well, the studies have all been done, and they've been done and done again. In fact, almost every water body on Long Island has been studied at least twice with regards to nitrogen loading, and they have all come to the same conclusion, and for Great South Bay included, that the majority of nitrogen entering the bay is coming from wastewater, and specifically these on-site septic systems that are designed to let the liquids just go right through them and into our groundwater source. And that's where all the nitrogen is. 80% of nitrogen wastewater is in liquid. So they do exactly what they're supposed to do. And they allow high concentrated nitrate wastewater enter right into our groundwater supply. Coupled with this problem, I also want to point out something that's usually overlooked, and that's the flushing of water bodies. And so what I've accumulated here is the tidal range of different water bodies all across Long Island. The North Shore, the East End, the South Shore. And I want you to note is that when we look at Great South Bay, we can see that the tidal range is smaller than anywhere else on Long Island. And what that tells us is that the water will flush slower. And that's a dangerous combination. High nitrogen entering a water body and then it not being flushed away by the tides, but rather sitting there. And when that happens, you end up in a situation where you can have a high risk for water quality impairment. And if we look at this map here that my lab group developed just last month, you see what the consequences are of low tidal flushing and high nutrient loads. So this data set, I want to emphasize, this isn't long-term monitoring. These are observations that were made on Long Island between June and September of 2020. And what this shows is literally dozens upon dozens of water quality impairments that occurred in Long Island during this time period. And when I say water quality impairment, I'm not making a judgment call. I'm using federal and state standards. So the DEC tells us what the levels of oxygen should be. They tell us what the permissible levels of blue-green algae, for example, should be. So when you see a number here, it's not me saying, oh, it doesn't look good. It's the DEC setting a quantitative standard that's not being met. And if we hone in on Great South Bay here, what we can see is firstly the occurrence of multiple low oxygen zones, as well as a fish kill that was documented in Oakdale, a mahogany tide that occurred across the northern extent of western Great South Bay in the June, and then a brown tide that was short in duration, but fairly widespread that occurred in June as well. And you can see these sorts of things, mahogany tides, brown tides, fall within the realm we call harmful algal blooms. Those two particular tides that I just mentioned, in some respects we can say are not as bad as some others. These are the 6 main ones that we have that occur across Long Island. And so at least we can say that the mahogany tide and brown tide aren't toxic directly to humans, but they are quite lethal to marine life, and have led to the collapse of multiple fisheries. And I showed you the trend in nitrogen, and the research is in when you have high levels of nitrogen, that can couple to cause essentially 2 outcomes. It can intensify the density of a harmful algal bloom, but for some of these toxic harmful algal blooms, it can actually make them more toxic, because for some of them, the toxins they make are nitrogen-rich compounds, and it's a very simple physiological outcome. Give them more nitrogen and they can make more toxins. The harmful algal bloom that's been of greatest consequence for Great South Bay for the past 35 years have been brown tides caused by the algae known as Aureococcus. This particular harmful algal bloom has really been a game changer for Long Island. You can see here, after the very first brown tides that occurred along Island, we had a significant dieback of seagrasses, both in Great South Bay, but also on the east end. Brown tides were responsible for the collapse of the scallop fishery in 1985 that has had a few small comebacks, but really continues to never regain the incredible prominence it had back in the 1980s and 70s. And then, of course, we know about the hard clam in Great South Bay. It's not just legend, it's fact that in the 70s and the 80s, more than half of the hard clams eaten in the entire United States came from Great South Bay. And again, it's not legend, but fact that the landings are now just less than 1% of what they were during the peak. Now we know, based on research, that the initial declines that occurred in the early 80s were due to overharvesting. Simply more and more licenses were being given out and this fishery was overharvested. But you'll see, here's 1985, there were still some clams there. The drop from 1985 that we have through to today has been, again, more than 95% of a drop. And that's despite continual restoration efforts. And you'll see why momentarily. And so we now have 35 years of brown tide data. And that's what I'm showing you here for Great South Bay. I'll give credit here to Suffolk County Department of Health Services, which really hosts one of the most significant water quality data sets in the country with regards to duration. This extends back all the way to 1976. But you can see here, it's a 35-year record of brown tides. And so, just some very quick highlights. The first one was in 1985. There was sporadic monitoring at that time. You can see the 90s through 2002 was a particularly bad time for brown tides, essentially recurring annually. We had a pause for about 5 years, an extremely dense bloom I'll reference again in 2008. And then since 2013, I don't have the data set through there, but I can say there's been annual brown tide since then. So we're in another era of recurrent brown tide blooms. And again, I mentioned that it was during this period where I did my first brown tide sampling and published my first paper on brown tides in Great South Bay. Now, I've mentioned that there's been significant effort in restoring the hard clam populations to Great South Bay. The Nature Conservancy took over the old Blue Point's oyster company bottomlands at the turn of this century and began to create hard clam spawner sanctuaries in order to try to restore this fishery. And you can see within just a few years, what you're seeing here are essentially heat maps of juvenile clams. And you can see within just a few years, by 2008, they started having a great set of juvenile clams, providing great hope that this would continue. But you can see that thereafter, the success had been somewhat sporadic. And what's interesting is that the up and down nature of these juvenile hard clams coincides exactly with brown tide blooms. I showed you the incredibly dense bloom that occurred in 2008 that wiped that fishery out. You can see it started to come back again by 2012, but since then we've had recurrent brown tides that have essentially brought that population back down to almost zero. I'm not going to belabor the new inlet because I understand that the last two speakers we had talked about it a lot. So I'll just talk about it momentarily because I will say that my group invested more than 5 years of research, essentially starting sampling the only weeks after this new inlet was formed. And once it was formed, I showed you already the low tidal flushing within Great South Bay. My original hypothesis was that, well, this new inlet's going to flush out the whole bay. It's going to be a game changer and everything's going to be much better. And we saw that to some extent. When we sampled, for example, right by the inlet, we saw brown tide levels were low. But when we went to central Great South Bay, we saw that that area was still vulnerable to brown tides. And getting quantitative with regards to the frequency of brown tides, you can see that while we had them on average, you saw them about every other year before the new inlet. In the center of Great South Bay, these blooms became annual events following the new inlet. Now, again, I'm not going to belabor this much, but I want to point out this paper that was published by my lab group. Again, it represents more than 5 years of data collected in multiple projects. This paper is free online. You can go right now and download it and read the whole thing. And it's quite extensive. I won't go into all the details, but I'll just give you some quick highlights that essentially showed the very regional influence of that inlet. So here is water clarity. Anything in blue is an increase in water clarity, red is a decrease. So you can see that water clarity getting much better in the region of the new inlet, but getting worse, significantly worse, for the rest of Great South Bay. In fact, for most of Great South Bay, and also even for Western Mauritius Bay. And similarly for nitrogen levels, while we saw levels decline, you can see negative numbers here in the blue, near the inlet, you can see the total nitrogen levels actually increased after the formation of the inlet. And so the final paper, figure of that paper gives this essentially, this flow chart, essentially showing that the increased tidal flushing of that new inlet resulted in statistically significant declines in nitrogen, turbidity or water, turbidity of the water, temperatures, levels of phytoplankton, and harmful algal blooms. And again, I don't have time to show you all the data. Please do reference and look at that paper. We saw significantly faster growth rates of hard clams experimentally in that region as well. And with lower light, we'd expect more seagrasses. But when you get further away from that inlet, the situation is different. There's no change really, or very little change in tidal flushing, but there is evidence that the levels of nitrogen loading are increasing. And so what we saw in the middle of the bay, therefore, was higher levels of nitrogen, more turbidity, higher temperatures, more algae, more harmful algal blooms, slower growth rate of clams, and we would expect, therefore, seagrass slower. I'm going to pivot now and talk about another consequence or another change we've seen in Great South Bay since the formation of the new inlet. And I'm going to start with this picture here. This is a picture where if you go to the coastline, you don't need a scientist to tell you that there's something wrong. This is in the Sayville region in September of 2019. And this is something that's actually new to Great South Bay. And it's in fact an invasive seaweed. I'm not going to go through the time course here, but the name of the seaweed is Daspsiphonia japonica. Now, japonica stands for Japan. This seaweed is actually native to the Pacific Ocean. But you can see from the timetable here, it began to invade Europe in the late 80s and 90s. It made landfall in the US just earlier this century. And what I'm about to tell you, or about to show you here, is it's now widespread through the Great South Bay and other regions on Long Island. This is a survey that we did in the fall of 2019, and you can see we could not find a location without it in Great South Bay. And in fact, we found it also in Shinnecock Bay and into the Peconic Estuary. And this was just on a single survey that was done. You know, it's possible we'd find it in even more places if we went on multiple days. Now, this seaweed can accumulate on shorelines when it overgrows. You can see this is some pictures taken, I believe this was in the summer of 2018. This, of course, is unsightly, but when this seaweed begins to decay, it becomes even more unsightly. And I don't know who might remember, but it was in this summer of 2018 where in the midsummer there was associated with when the seaweed looked like this, a tremendous smell that came up across both Fire Island and on the mainland. We called it the big seaweed stink because we saw that these seaweeds were growing robustly earlier in the summer, but when they got to peak temperatures, they began to die off and release sulfur that led to that smell. Now, of course, we can joke about sulfur smells and such, but there's actually emerging medical evidence that hydrogen sulfide release from seaweeds can be a serious medical issue. You can see a similar wash up on the shorelines in the Caribbean. And this paper published in The Lancet, which is the second most impactful medical journal on the planet, demonstrated the whole host of medical issues that can arise from exposure to high levels of hydrogen sulfide. And in fact, on one Caribbean island of Martinique, they had more than 8,000 admissions to the intensive care unit over just an 8-month period due to exposure of hydrogen sulfide from seaweeds. So this can be a human health concern. Again, we see water like this, we know there's a problem, and the question is, why is this particular seaweed here? We have a paper that's about to be published in the Journal of Biological Invasions. I'm summarizing some experiments that we did here that look at the growth of this seaweed in the presence of no amendments whatsoever, giving it more nitrogen, giving it more carbon dioxide, or giving it both of these things. And so the answer we get from this experiment is crystal clear. This species grows faster when it's given more nitrogen or more carbon dioxide, and it grows absolutely fastest when it has a maximum amount of each. Now, of course, we know CO2 is rising in our atmosphere and in our coastal waters. I'll also just mention to you that we know that high levels of nutrients can synergistically promote high levels of CO2 as well, a process we call coastal acidification. Now, to better understand the nutrient relationship, during that survey that I showed you before, we collected those seaweeds to identify the type of nitrogen that the seaweeds were utilizing. We used isotopic tracing, specifically of the nitrogen atoms in the seaweed, and by doing that, you can clearly differentiate the nitrogen that's coming from either from wastewater or from fertilizer. And that result is shown here. So the N15 or the delta N15 signal can be negative, down to -3, or it can be positive. And if it's -3, that means the seaweeds are utilizing fertilizer. And if it hits 10, it's using just wastewater. And anything below that might be a mix of the two, with the closer you are to 10 being that would represent how much of the nitrogen is coming from wastewater. And so the results for this survey all across the South Shore, and you can see specifically all across Great South Bay, couldn't be clearer. This seaweed is using nitrogen from wastewater to bloom throughout Great South Bay. Now, this doesn't look pretty, and I already showed you this could be a human health threat, but unfortunately, that's not the end of the story, because beyond that, this seaweed is also detrimental to marine life. So we've done experiments where, for example, shown here, we've exposed larval fish, Menidia berylina, to either the live algae, in which case they do okay, or the situation that we had here that I showed you, that horrific looking picture of the decayed algae. And you can see the fish just cannot survive in the presence of that decayed algae, even though the exposure was the water was filtered and the water was rigorously bubbled to prevent any drop in oxygen. So this is not an oxygen issue, it's not an ammonium issue, but some kind of bioactive compound that's being released from this algae. We saw a similar effect on hard clam larvae that's shown here, where in the presence of the live algae, there seemed to be no problem. But as soon as you give it the filtered algae, which is shown here and here, you get a significant decline in the survival of those larval clams. And so I won't go into too much detail here. I'll just keep moving. But here are just some of the highlights of what I just showed you. I now want to move on to the water quality index that my lab runs for Long Island. You can see this is a collaboration with News 12. Bill Corbell used to report this every Thursday nights during the summer on a half an hour between May and September. And you can see here that everything got a ranking, good, fair, and poor. And again, thankfully, this wasn't a judgment call on me saying, no, the water looks good. But we're using New York State Department of Environmental Conservation standards and US EPA standards to come up with a precise number that then would lead to these rankings. And so we have now more than 6 years of data, and I'm just going to show you some averages from all across Long Island here. And so here's our survey, for example, of total chlorophyll. And again, the US EPA and NOAA would tell us that you really want to be below 5 and you never want to be above 20. And here you can see breaking out all of our locations for the North Shore, South Shore, and East End. You can see here for Great South Bay, the middle of the bay is in the red zone. It's above that level. And this is, I should say, on average, that we never want to see. And you can see even the other areas are not achieving the level where you ideally would be. And again, even the Western Great South Bay Station is getting close to the 20 as well. Another snapshot I'll show you is dissolved oxygen. That's shown here. The New York State DEC would tell you that you ideally would have oxygen levels of always above 4.8, but you never want an oxygen level below 3 because of the damage that can do to marine life. And so you can see here, Great South Bay is not alone in having sites. You can see 2 of the 3 sites on average was below that standard. You can see the Fire Island Inlet was between the two standards, so it didn't make the chronic standard, but it did make the acute standard. And I have Bayshore Cove here, but I will just mention that this is probably not an accurate, this is based on individual measurements. I should say, when we measure oxygen for most locations, we're using chronic oxygen logger, so measuring oxygen every few minutes to give us a real picture. Unfortunately, we didn't have a logger, or don't have a logger set up for Bayshore Cove, so this is a static measurement. And I can tell you what we've learned when we've done paired observations is that when you measure oxygen during the day, the oxygen levels generally look good. In fact, that was the conclusion Suffolk County had for about 30 years or 35 years. There's no oxygen problem in Long Island until we started making these chronic measurements, because what we've learned is that at night, you have what's known as nocturnal hypoxia. Here's an example of that. This is from my lab website. We have multiple sites that are actually still in the water, where we're chronically measuring 6 or 7 different parameters. You can make your own graphs on this website, choose your time frame. So I'm just choosing here, I'm showing you this past summer for Bellport Bay, just as an example. And what you see is the data looks really messy, right? It's all squiggly and such. And that's because of the day-night variability. And so the reason Bayshore Cove looks good is we're measuring during the day. Yeah, that oxygen looks great. There's no problem here. But the reality is it's at night when you have the low levels. And you can see when we get to late summer, we're going below that New York State DEC standard almost every night. And recent emerging research from my lab and other places have shown that these day-night cycles and these, what we call nocturnal hypoxia, has important negative consequences for larval fish and larval shellfish. I'm going to wrap up with what we might be doing about these impairments that I've been showing you, and that is, how do we get from a situation where we've got our declines in shellfish and harmful algal blooms to a situation where the shellfish are revived and we have a plankton community that's supporting healthy ecosystems with seagrasses and extensive salt. And I've showed you that septic tanks are the biggest source of nitrogen to, cesspools are the biggest source of nitrogen to Great South Bay. There's 360,000 unsewered homes in Suffolk County. You can add on to that another 140,000 in Nassau County. And the issue is that, again, those systems are leaching nitrogen directly into groundwater. I had to modify this figure because in recent testing that we've done, and I'll shortly mention the Center for Clean Water Technology that I direct at the university, we've actually been sampling septic systems. The national average is about 60 milligrams per liter, but we keep seeing these homes where the effluent is actually 100 milligrams per liter, sometimes even 200 milligrams per liter. Now, thankfully, we live in a county where the initiatives to upgrade the septic systems are unparalleled in the United States. So if you're not aware, the Suffolk County Subwatersheds plan was just released in, the draft was released in 2019. This plan was finalized in 2020 to come up with an aggressive, forward-looking plan for essentially upgrading more than 200,000 systems all across Suffolk County over a decadal time frame. And so in very good news, what you can see is that this is the the sewer region for Great South Bay, the Southwest Sewer District. But what you can see, what this plan calls for is all the rest of the watershed for Great South Bay to be converted to IA systems. In fact, in the very next phase of upgrade. And there are, thankfully, systems that have been approved by Suffolk County that do a good job of removing nitrogen. I mentioned I direct the Center for Clean Water Technology at Stony Brook, where we have a goal that we call 10-10-30. We want wastewater systems to get nitrogen down to 10 milligrams per liter, even though the county standard is 19. We want to get to 10 for human health concerns. We want these systems to cost $10,000 and last at least 30 years. And our first attempt at this, nitrogen removing biofilters, are designed to do just that. And again, in the interest of time, I can't go through the details, but I can tell you we are getting down below 10 milligrams per liter. These are simple designs based on natural products of sand and wood chips that utilize a drain field. And some of our preliminary data were achieving levels of nitrogen effluent that are as good as or better than most of the commercially available systems. The last thing I want to talk about is what we could call in the water mitigation approaches. Unfortunately, groundwater can have a decadal travel time. And so because of that, even actions we take today may take decades to be realized with regards to water quality. And that's why we want in the water solutions for mitigation to be occurring as well. And so in 2017, I got a call from Governor Cuomo, who had asked about something that we were doing out in Shinnecock Bay, known as the Shinnecock Bay Restoration Program. He came out to see that program in May of 2017. And in fact, I should say, he came out partly because he had heard about the brown tide that was going on in Great South Bay at that time. And he knew he was making tremendous investments in wastewater infrastructure and wanted to know what could be done in the water at the time that harmful algal blooms were occurring. So I introduced him to the Shinnecock Bay Restoration Program. Through the summer of 2017, I worked with the governor and his staff to help develop the Long Island Shellfish Restoration Program, which consists of 5 different hard clam spawner or shellfish sanctuary locations across all of Long Island, including one in Bellport Bay and one in South Oyster Bay. And these particular locations were specifically chosen because we knew that putting clams directly in the middle of the bay is probably not a good idea. I've already showed you what can happen. Those shellfish aren't going to survive. So the idea is to put them on the margins so those populations can begin to improve water quality and slowly repopulate the bay from the margins. And that's the approach we had used in Shinnecock Bay and has been fairly successful. And so there's multiple organizations involved here, including Cornell Cooperative Extension, who is in charge of juvenile shellfish. Stony Brook has been charged with creating adult hard clam spawner sanctuaries where we're putting out adult clams, with the idea being that if we put many adult clams together, because they're broadcast spawners, they will then produce offspring, larvae, that, as you can see, that are mobile and then can begin to repopulate the bay and then continue to build the stocks of hard clams in Great South Bay. Okay, so with that, I'll just wrap up and say that we've had wastewater contamination of our groundwater, and this has led to things like the daisy invasion, Daspsiphonia, brown tides, and low oxygen conditions. Conversely, though, reducing nitrogen will improve the conditions within Great South Bay, and those sorts of watershed approaches, as well as in the water approaches, are going to be needed moving forward to help restore Long Island coastal waters like Great South Bay. So with that, I will thank you for your kind attention, and I'd be happy to take questions.
Well, thanks, Chris. I really appreciate your time today. That was a very informative presentation with, and I want to say thanks for making it so digestible for people who may not have the scientific background. That was very easy to understand, and you painted a very clear picture for us of where the health of the Great South Bay is. We also, as part of our action plans, include nitrogen reducing programs such as our bay friendly yards. So I'm curious to hear some of the questions from our other audience members, and I'd like to kick off the Q&A with by introducing Todd Shaw, who is the president of the board of Save the Great South Bay. Todd, could you unmute yourself if you want to ask a question?
I see a bunch of questions that are in the chat. I could start addressing those, or I could take other questions.
Yeah, just give Todd 1 second. He had a couple other questions in the chat.
Hello, Robin.
Yes, hey, Todd.
Hi, yeah, no, all my questions have actually been answered, but I just wanted to thank very much, Dr. Gobler for taking the time. So informative. We appreciate you, your presentation.
You are welcome.
Great. Okay, so Chris, Andy Michelle, who's our West Islip Creek defender, asked about hypoxia in the Fire Island Inlet. It seems almost counterintuitive that in an area with such great flush.
Yeah, and so I'll just say that our monitoring site there is the Coast Guard station. So as we're all well aware, that's a mile-long inlet. And so this is something we saw this summer, we've seen in past summers. We're out there monitoring all the time. We have data loggers that are actually in the water monitoring the oxygen levels every 10 minutes from May through September. And if you didn't know, just by laws of physics, gas laws, the levels of dissolved oxygen in seawater are inversely proportional to temperatures. So that's without any biological activity. So as you move through the summer and you get to times where the water temperatures hit 30 degrees centigrade, for example, into the mid 80s, the just natural background level of dissolved oxygen get down to, say, around to 6 milligrams per liter. And so we're just in a little bit of additional biological activity that can bring the levels down even lower. And so essentially what we end up seeing is that time of year, so late summer, at night on an outgoing tide, you can actually get the hypoxic water from the bay moving through that Coast Guard station. It really only lasts for a week or so, but we've seen this is, I think, the second year in a row that we've seen the levels get below New York State DEC standard.
Wow, thank you.
You're welcome.
That was a good question. So Ethan Dutney from Dune Fishery and Gina Macho Foundation had a good question. Ethan, you want to unmute and ask, or? All right, we'll come back to Ethan once he gets unmuted. Thomas Schultz from Friends of Bellport Bay had a question regarding the inlet and the flush in the Great South Bay. Go ahead, Thomas.
Thank you, Robin. Thank you for sponsoring this organization. Professor Gobler, nice to see you again. As you know, we in Bellport Village have been a proponent of the inlet, and I do refer to it as an inlet. In fact, I refer to it as Bellport Inlet, just like Shinnecock and Moriches Inlet were both created by hurricanes, so was this inlet. So with that said, you did mention in your presentation that the central part of the Great South Bay has experienced a decrease in clarity and an increase in nitrogen since the inlet was created. It appears that you may be connecting this degradation to this part of the bay to the creation of the inlet. Is it possible that the levels in the central part of Great South Bay would be worse than they are today if the inlet did not exist? And are you saying indirectly that the inlet may be causing these adverse effects in the central part of Great South Bay?
I think that we can't make absolute 100% definitive conclusions about that. But the data does speak for itself, and that since the inlet's been formed, there's been more brown tides, which has led to lower water clarity and higher levels of nitrogen. Whether the extent to which that's directly due to the inlet or a second factor that goes along with it, I guess, still can be investigated. But certainly, there's no doubt that we had a period going from 2002 to 2012, so for a decade, where there was really only one major brown tide. And then post-inlet, brown tides have been occurring every year. So that's just the data, and we can all interpret that however we want. But the benefits to the eastern part of the bay are clear as well. But this is something we call, I think it's very important to recognize. We would call this potentially the law of unintended consequences. Anytime you alter the physical circulation of an estuary, it can be complicated with regards to how it's going to affect the ecosystem. And I'll just give a parallel example just very quickly. In just due west of Great South Bay, when they put in the outfall for the Bay Park sewage treatment plant in a place called Reynolds Channel, this is a channel that's between two ocean inlets, the Jones Inlet and the Far Rockaway Inlet. Seemingly would be the perfect place to put sewage outfall because it would then be flushed right out of the bay. Well, as it turns out, the Jones Inlet flushes due east, right? Does not go to the west whatsoever. And that sewage outfall keeps getting sucked north on the tides. And so, and that's just the same exact idea. This new inlet, the Bellport Inlet, I love that name, communicates very well to the east, to the Moriches Inlet, but it does not seem to have that same push to the center of the bay. And this is, again, this is, and it parallels perfectly what we see for the Jones Inlet, and even the Shinnecock Inlet, which flushes due north very well, but only has a certain extent to the west.
Thank you, Dr. Gobler. I have a follow-up question to that on behalf of, so in conjunction with that question. So in one of our recent presentations, we have heard of something called legacy pollution. And legacy pollution is pollution that starts, everything we know, I think we know, that everything from the expressway down moves south. Right. And so if you consider the development that happened here about 50 years ago along the expressway, I know my parents moved out to Medford in the early 70s. There was a lot of development going on in the Centery-Ronkonkoma areas at that time. If the cesspools that were put in, if this moved at about a foot a day, it would have reached the bay around 2010. So is it possible that just happened to coincide? I mean, of course, there are always multiple theories, but is it possible that the legacy pollution happened to coincide with the opening of the Bellport Inlet and to increase the nitrogen on the western side of the Great South Bay?
Absolutely. And in fact, if you, again, that paper that I referenced is free for anyone to read. And those images I created refer to that idea that, yes, exactly. That nitrogen is continually, the nitrogen from decades ago is making its way into the bay, and the levels that are being discharged into the bay are higher and higher because they're reflecting, like you said, activity and development that occurred decades ago. So absolutely.
So Todd, I had a question about a potential inlet similar to the Bellport Inlet at Gilgo. It's an idea that we are exploring as an organization and having conversations around. As we do know, Robert Moses had closed the Gilgo Inlet in order to construct Ocean Parkway. Again, that might have taken a few decades or so, or just even a smaller period of time to have an effect on the bay that might now be compounding over now that it's been closed for several decades. Do you think that the opening of an inlet that would allow flush to the western part of the bay would help? We're not proponents of the solution to pollution is dilution, but that the flush might be helpful for helping clear out the western part of the bay?
When you think about where Gilgo is, I'm not sure that is an ideal spot for enhancing flush to western Great South Bay. Recognize, again, as I just said before, so it's good that Thomas had asked this, the tidal flushing between the Jones Inlet and the Fire Island Inlet is very, very good. And in fact, the water quality, therefore, in South Oyster Bay is actually pretty darn good. You have really good flushing there already. So I would argue that actually, if you added another inlet there, I'd be hesitant.
Yeah.
Because it's possible that you then, instead of having that great flushing all the way to the Fire Island Inlet, the Jones Inlet then might only go as far as your new inlet. And you could actually have things not as good further afield. So,
it's certainly an idea that would have to be modeled.
More in the middle of Great South Bay, I think the likelihood would be higher, but I'm not so sure about Gilgo as the ideal. If you're interested in flushing Great South Bay, I'm not so sure that's the best location.
Thank you. I do want to add to that Gilgo would not be creating a new inlet. It would be restoring an inlet that was there at one point.
Right, but again, I got to emphasize, we know what the flushing patterns are now, and we know how adding new inlets change flushing. Right.
It's absolutely an idea that would have to be modeled, and that's the point. That's the point that I think we're at now, is looking to Stony Brook for some. We're actually looking for funding we're looking for money to fund the modeling. Of course, it would have to be greatly tested before anything. It's a huge project.
Absolutely.
So here's a question. That was Todd's question. There was a question from Ethan. He was surprised about the lack of impact on Patchogue Bay that the Bellport Bay is not, the Bellport Inlet is not flushing or having such a great impact on Patrick Bay. Maybe you could speak to that?
Yeah, and so I would just, it's a non-uniform tidal flushing. So that new inlet, the water isn't going straight in and then east and west. Rather, it's going straight in and mainly east. And that's why that it's not, you don't see an enormous change or hardly any change in Patchogue Bay.
Got it. Thank you. From Melissa Parrott over at Suffolk, the Pine Barrens Commission. Why would Fire Island Inlet have lower DO, so dissolved oxygen, than Shinnecock?
Right, because again, we're measuring, at Shinnecock, we're measuring right by the inlet, whereas the station for the Fire Island Inlet is at the Coast Guard station, so it's further back. And that, that mile-long inlet for the Fire Island Inlet, it takes a while for that water to get through. So you actually essentially, and there's, overall lower tidal range, as I already demonstrated as well. So lower tidal range, longer inlet, and the fact that we're measuring at the back of I wouldn't call it the back, but where the Coast Guard station is versus right near the inlet for Shinnecock.
Terrific, thank you. Stephen Custer asked, and I think this is asked and answered, what are the effects of mahogany and brown tides on oyster populations, and what time of year do these harmful algal blooms typically occur?
Yeah, so both of those, the mahogany tide usually precedes the brown tide. Mahogany tides are generally, say, May into early June. Brown tides this year can overlap a little bit, but it can also go into July. They're both harmful to what we call early life stages of shellfish, so the stages, whereas adult populations are somewhat more resistant.
Got it. From John Hall, what is an IAOWTS system?
Yes, I should have said that. IA stands for Innovative and Alternative. Innovative Alternative On-Site Wastewater Treatment System.
Thank you.
Thank you, Chris.
Yes, I should have. Sorry.
I had another question since you're on me.
Sure.
Does your research point to any particular priority order of things that would need to be done to address the bay? We should be advocating. We're advocates. So,
sure.
Where do we go first?
Great question, John.
Well, I mean, I think parallel tracks make sense. And the parallel tracks being the one track addressing the watershed-based nitrogen load would be the one track, and the second one would be what I'd call in the water remediation. So shellfish, for example. My lab group has also been working on seaweeds and what we call bioextraction of nutrients via seaweeds, and that's showing some promise. And I don't think it hurts to better understand the circulation of the bay. There's no doubt that poor flushing is part of the problem there. But again, if the new inlet taught me anything, it was that don't necessarily expect that a large inlet is going to solve all of the problems. And that,
right.
Yeah.
Right.
Thank you, Chris.
What can people do? What can individuals do in order to, apart from, changing out if you still have a cesspool, apart from changing out your cesspool to one of the IA systems, we propose as part of our Bay Friendly Yards program that people start where they stand in their own yards, reduce nitrogen by eliminating or reducing the use of fertilizers and pesticides, manage stormwater on your properties to reduce the amount of runoff that goes out into the streets. And one of our biggest or third essential elements in a Bay Friendly Yard is to plant natives. Natives tend to have that ability to absorb nitrogen. We've decimated so much of our native habitat that a huge restoration effort might, again, all of these pieces are just pieces of the puzzle. Like you said, they have to go horizontal or, on the same tracks.
Mm-hmm. Yeah, I mean, I think those are all good things. You can, at one point a few years back, I developed an online program for looking at your nitrogen footprint. And, it sounds like everything you're talking about there addresses the individual nitrogen footprint. I'll just mention that the other part, the only thing you hadn't mentioned is that actually diet can actually play a role in nitrogen as well. If you didn't know, people who eat a lot of meat tend to excrete a lot of nitrogen versus people who are vegans, but not telling them what to change their diet.
Yeah, that's interesting. One of my questions I had jotted down is, why is our effluent so high in nitrogen?
Yeah.
I mean, I
well,
could probably open a door to many snide comments with that, but go ahead.
Yeah. I don't really have the perfect answer there. Recognize also that it's, the more the water is diluted with, the more wastewater gets diluted with other things like showers and washing machines, that actually dilutes down the concentration of nitrogen. Because it's really, that's the main source in the home is, just being perfectly honest and frank, it's urine.
Yeah.
And so, I will say also, there are some cases where homes in the past have been plumbed, probably not legally, such that things like the washing machine doesn't go to the tank. That could also lead to it.
Right, okay.
Yeah.
Thank you. I'd like to welcome Rihanna Quinradi, our newest board member over at Save the Great South Bay. Hi, Rihanna, thanks for joining us. She asked, what is the time frame for the new sewer initiatives to have a positive impact on the Bay? If coupled with the oyster projects, does that change the time frame? Great question, Rihanna, thank you.
Yeah, so I think, there's a few things going on there. There's, when it comes to sewer districts, there is the idea of expanding some of the ones that exist. So for example, picking up homes around the Southwest Sewer District. And then there's, of course, upgrading the individual on-site systems as well. But I think, and yes, those should be done in parallel with in the water solutions, because it depends where you are. The travel time of groundwater increases. If you're living right on the water's edge or very near the water, the travel time from your home to the ground and travel time of the groundwater from your home to the bay may only be a year or two. But if you live all the way up, say, Long Island Expressway, it could be 100 years. So that time to impact depends on where you make.
Thank you. I was just wondering if we would see a change in my lifetime, to these wonderful waters that we're trying so hard to save. So
yeah, I think we can with a concerted effort, and but I think I'll also tack on to that as an answer that this is for future generations as well. I just got to be honest. I give a lot of credit to the current administration of Suffolk County. The issue that has been known, the problems with regards to septics have been known for decades, and so this administration has taken on this issue, despite the fact that there'll be no benefits seen within the voting lifetime of the current administration. So that's pretty brave. And I think also we can all think about that the efforts that we put in today that will lead to improvements for both drinking water and surface waters for future generations.
Mm-hmm. Absolutely. Thank you.
Thank you. So Vivian Stoyanov asked, sorry Vivian if I'm completely butchering that last name, are there any studies or simulations to understand the effects of currents in the bay and the estuaries from the surface to the bottom of the bays? I will jump in on that question, Dr. Gobler. Last week we had Charlie Flagg on, and he presented his data on drift studies. So Vivian, if you want to check out our YouTube channel, we did a whole presentation on drift patterns in the Great South Bay last week. It was fascinating to see how the water actually moves. It's not as intuitive, doesn't move as intuitively as you might think. John Voigt, thank you, John. Tanner Park Beach is the third most polluted in the U.S. It's across from Gilgo. John, I know you are involved with, if you'd like to unmute yourself, you are involved in the new project at Venetian Shores over in the Copiague-Lindenhurst border. Did you have a specific question?
Well, not really. Just the one thing everybody needs to consider. Town of Babylon's rise to national prominence is having the third dirtiest beach in the U.S., and I don't think that's something we should be proud of. The American Venice Civic Association is in the process of working on a living shoreline. We have some areas that we're trying to do everything from native plantings to oyster restoration, just a small area down here. And with that, hopefully, we can work with other organizations and have that spread. So again, thanks for everything everybody's doing here. The one question here about the outflow pipe was the same question I had. What kind of impact, when that's up and running, is that going to have on the Great South Bay?
Yeah, I think that is going to be significant, actually, because I actually know some of the engineers who are working on that pipe, and it's just very clear that that aged pipe had been leaking. And so I think the restoration and the rebuild of that pipe is probably going to have a positive impact, particularly in that region, I would say.
Could that be one of the contributing factors to the western Great South Bay? I do a lot of boating over at Cedar Beach, and that pipe runs right past there, and that's exactly where you're having those super high levels of nitrogen.
It certainly isn't helping.
Mm-hmm.
And like I said, so I am optimistic. I don't, it's hard to put a number on it. I do just one thing that just occurred to me with regard to Tanner Park and Gilgo Beach. I just want to share a parallel story from Shinnecock Bay. We talked about modeling. The state government just paid for a very large modeling study to consider making a new inlet in Shinnecock Bay to look at in the ocean side, to look at the effects on the bay. And what was really surprising is that, you made the cut on the south, obviously on the Barrier Island beach, and the flushing around it is great. But the shocking thing is that the flushing time of the water just to the north was actually slower. So that water actually became more stagnant in the area due north where that inlet was made. And again, I would never have predicted that. And I'll say they abandoned that whole consideration when they saw what the result was. They saw the levels of fecal coliform bacteria on the north, to the north side of the bay were going to go up, and the levels of harmful algal blooms were going to go up. And they just scrapped the whole thing and putting it on the south shore, because they realized that they were actually, instead of making it, they would make it better along the south part of the bay, but they would make it worse along the north part. And so the whole idea was thrown out. It was done by a consulting firm called Dewberry.
Thank you. With respect to, with everybody's time today, we have 3 minutes left, Dr. Gobler. So I'd like to ask the 3 last questions from Janice Bernichon. Would a one-way inlet where the water can flow either into or out of the Great South Bay along the Jones Island, say near the Bergen Point outfall pipe, help flushing of the central portion of the bay?
I'm just going to say hard to say, because I'm not really familiar with those. Like I said, the study I was just talking about considered one-way pipes, but the pipe was just on the south shore.
Right. That's certainly something that would have to be studied. Sorry, we're not meaning to put you on the spot here. What are your thoughts on short-term use of massive seaweed farms as possibly a quick and effective mitigation technique? Certain seaweeds have an impressive ability to uptake nitrogen.
Yeah, and my lab group has been working on that pretty vigorously the last several years. We've been growing kelp, for example. We're yielding 10 pounds of kelp in just 1 foot of line.
Wow.
Biomass. And we've been doing 100-foot lines. So literally we've been pulling out tons of seaweed biomass over the past couple of years. Kelp is seasonal, however. It's a winter crop. So we're also considering some summer seaweeds as well. So I am optimistic that can be a useful bioextraction approach. And so we're working with some oyster farmers on spinning that up to see how it can be scaled.
Thank you. Thank you, Chris. Are there any seaweed projects going on in the Great South Bay right now?
So we've been working with Matt Welling on 13 oyster farm. Yeah. And so we've had some good success there. Last year, the kelp growth rates were great. I will just say, firstly, importantly to point out, growing seaweeds right now, you can't do it commercially. So we're able to do it because we're getting from the New York State DEC experimental permits. So it's really in a sort of nascent phase that the DEC will not permit commercial growth of seaweeds. Right. But by working with Matt, we were with the DEC able to get experimental permits, and the growth rates were quite good.
Terrific. And as I understand, the seaweed absorbs nitrogen from the water?
Yeah, in fact, it has to, it's its only option. So it's taking out nitrogen, phosphorus, and carbon. So it's also addressing climate change to some extent as well.
That's something people could grow in their backyards.
It's Dan Boyd.
It grows in the so it's got to be in the bay.
Gotcha. No, I meant if you live along the water on the bay.
Well, right now the answer is no, because again, it's only permitted for experimental.
Gotcha.
So they're only getting experimental permits. But I'm optimistic in the future. The answer would be yes.
Terrific. And our final question is from Mayor Dennis Siri from over at Amityville. Mayor Siri asked, so then is saving gray water for watering yards not particularly beneficial towards nitrogen reduction?
No, I mean, in the end, the amount of nitrogen is the amount of nitrogen. It's just you end up with a stronger nitrogen concentration in the wastewater effluent. And you know, maybe it is somewhat, there is something to that. When the levels are really high, it's possible that your removal in some of these innovative alternative systems might not be as efficient.
Gotcha. Well, Dr. Gobler, thank you so much for your time today. This was extremely informative. I'm glad we had a lot of time for questions at the end. It was terrific to spend some time with you today, and I hope we can welcome you back to our speaker series again in the near future.
Okay, well, that would be my pleasure. Thank you, everybody, for your kind attention, and look forward to seeing everybody somewhere at some point.
Thank you, Christopher.
We will be posting a link to this presentation that has been recorded onto our YouTube channel. Dr. Gobler, if you would be so kind as to send us over a copy of your presentation, it would be great for people to have to follow along with. Thank you, everybody, for joining us, and have a happy Thanksgiving.
Thank you, and thank you for organizing, Robin.
Thank you. You too. Thank you, Rob.
Thank you.
Goodbye, everybody.
Bye-bye.
Bye-bye.